In this video, the connection between steel element of a storage tower not subject to fatigue loads are analyzed. In general, this element supports silos, machines, wave feeders, etc. In storage towers, the weakest points are usually in the joints between elements, and that's why special attention must be paid to its design and calculations. Furthermore, the integration of two engineering software, SAP2000 and RAM CONNECTIONS, is discussed in the video. Both will be used to automate the process and organize the large amount of data and information collected on the building. Here, bolted connection will be thoroughly analyzed, but welded hybrid connection will also be discussed. Bolted connection are modeled by pinned joints. Pinned joints are created in software by releasing bending moments. So let's get started. The main function of connection is to hold the part of the structure together, supporting both their own weight and the load exerted upon the structure by external loads. A defective connection can also cause total collapse. However, they can also be designed for other purposes, such as dissipating energy. In order to properly design connection, the minimum load and the strength requirements must be consistent with the standard for connections. Wind, seismic, operating and gravity load must be considered in the analysis. Design procedure. First, the load values are extracted from SAP2000 for the worst case scenario, i.e., the maximum component of the stress envelope are selected. The worst case scenario is not necessarily when a load is at its maximum. When several load cases are presented, all valued combinations must be considered, since the combined effects of several smaller loads can be the most damaging. Then, the person performing the analysis will determine the transfer force based on the forces obtained with the software. Transfer force consists of loads that are transmitted across the joints in the structure. The determination of transfer force can be time-consuming, but it is an essential step in the design of safe and cost-efficient structures. Second, depending on the nature and direction of the transfer force, a series of filters can be used to short them and obtain the worst-case scenario. Third, once the maximum value has been obtained, the connection elements such as plates, bolts, nuts, etc. must be sized using regularity values. At the end, the stress values are entered into RAM connection, taking care not to make mistake and careful checking the input data format. The number of connections in this type of building is extraordinary. They are around 55 just for a simple floor and up to 400 in a more complex one. Considering that we have more than 7 floors in this building, the number of connections can be overwhelming. Obviously, unfortunately, not all of them will be calculated. In the connection design, a series of typical connections and the maximum resistance are determined. Then, all the connections of the structure are classified according to the shape and their maximum loads. In this approach, the load values on each connection do not matter. It's only important that the maximum load is not exceeded. Finally, the connections that do exceed the maximum load are classified as special joint and are calculated separately. Standard connections. The most common type of connection are the 90-degree beam column, the beam column brace, and anchor bolts. However, there can also be other standard type of connections like bracing anchor plates and stair beam to main beam, but are not as commonly used. Codes and regulations. Now, let's briefly talk about the applied regulation. In the connection design, the reaction combination are obtained according to AS CE7-16, Chapter 2. The allowable stress of the steel plate, i.e., plate shear, rupture, and block shear, were checked with AIS C360-16, Chapter J. The shearing bolts and fillet weld were checked using the AISC Steel Construction Manual. Splices, bracing connection, skewed beam, and anchor rolls will be detailed below. Splices. Determining the position of the splices in column is quite simple. In general, a steel structural element is not more than 12 meters long. When columns are longer, splices must be used to maintain continuity. Also, splices should be at a distance of 1.2 meters from the nearest platform so that they are easily accessible in the assembly process. Bracing connections. A standard vertical bracing connection is calculated using only the axial tensile force which the bracing resists. Braces should never be subject to compression loads, or at least, because of how slender braces are, the resistance to compression load should not be considered in the analysis. The only tension tool in SAP2000 can be used to model this condition. Skewed beams. The angle at which two beams meet can be straight or deviated. In the latter case, due to the deviation, the flanks must be cut considerably and the web is left unprotected. Those cases are known as skewed beams and are resolved by reinforcing the web with plates on both sides. Anchor bolts at the base of the columns shall provide the required resistance to load on the completed structure. The anchor rod shall be designed in accordance with the requirement for threaded parts in ACI-318, Chapter 17. Pull-out, concrete breakout, concrete splitting, bond failure, and other effects must be avoided. And that's it. Thank you very much for your attention. If you have any comments about this video or you need more information about steel connection, please do not hesitate to send me a message.